Hello, welcome to this video today. This is going to be about power. So power is defined as the rate at which energy is transferred or the rate at which work is done. So the first equation we're going to be looking at is power equals E over T, which equals energy transferred over time. This gives power the units of joules per second, and this unit is called a watt. So 1 watt equals 1 joule per second. The second equation that also describes power is P equals W over T. W is work done, T is time. This is essentially the same equation, as it produces the same units and the same outcome. However, work done is considered slightly different to energy transferred. So the work done, just given by the symbol W, equals force times distance. S is the symbol for distance. Work done, which is measured in joules, allows us to work out the energy transferred by a force. It's equal to the strength of the force, measured in newtons, multiplied by the distance travelled along the line of the force. It's measured in meters. When it comes to comparing power ratings, it's not completely obvious what's the object or motor with the most power, because obviously it's dependent on time, and as time decreases, obviously when your denominator is a smaller number, the overall number is going to be higher. When you divide by a smaller number, you get a larger number. So we're going to be comparing three motors. We're just going to call them motor A, motor B and motor C. So motor A will be lifting a 5 kilogram block 5 meters high, and it's going to take 1 minute to do that. Motor B is going to lift a 15 kilogram block by 0.8 meters, and it's going to take it 25 seconds. Motor C is going to lift a 2.5 kilogram block by 25 meters in 40 seconds. So different things about all of these. So for example, motor B is lifting the heaviest weight, motor C is lifting it the highest, motor B is lifting it the lowest, or motor B is lifting it the fastest in 25 seconds, or motor A is lifting it in 1 minute, which is obviously the longest of the three. So there's quite a few different parameters here, and we've got to explore how that's going to affect the overall power. So we're going to work out the energy transferred by each motor by lifting the block, the amount of meters that it says in the question. So for the first one, we're obviously getting MGH. It's going to be 5 times 10 times 5, obviously 250 joules. Motor B is going to be transferring 120 joules, and motor C is going to be transferring 625 joules. So from that we can obviously see the most energy transferred is motor C and the least is motor B. Now we've got to change all the units of time to seconds. Obviously for motor B and motor C that's very easy, it's just 40 and 25 seconds, and obviously 1 minute it's easy enough to transfer, as that's 60 seconds. Then we're going to plug all these numbers into the equation. So obviously we're writing down the equation, P equals E over T. We're going to plot the energy transferred over the time. Now this is going to give us some varying power ratings. So for motor A we get a 4.2 watts, for motor B we get 4.8 watts, and for motor C we get 15.6 watts, which is by far has the highest power rating. But I would argue that's not completely obvious by the setup of the question. So I think that's just a thought to leave you with on how it's maybe important not to just assume that you know what the question's going to be.